What we're going to show now is one of the new 3D milling features available inside FeatureCAM 2009. Now this example looks at what we call a contact point boundary. So FeatureCAM now allows the user to create contact point boundaries based on the tool geometry. So initially what we have is a simple 3D model just to highlight how this process works, and what we have is a simple circular boundary that we're going to try and machine within. If I view from the top here, here's our boundary, here is my surface milling process. So I've got a parallel process. What I want to do is I want to machine within that boundary. So let's just look at the boundary itself. So we go to the stock tab, I'm going to say show combined boundary, and we're basing the limit of that on the tool center. So we calculate and we can see the blue region. This is the region in which the tool center is going to stay within. So let's preview this. Play that process. Just turn off the shading just to make it a bit clearer. So here we can see the tool center point track. Okay, it's highlighting on the toolpath there, and you can see it's staying within that boundary, so it's not violating the boundary at all. However, if we rotate around to the side, we can see that the tool center point doesn't actually reach the base of these surfaces. So let's view from the left. Let's just run through in a single step, and we can see there is the tool center point, and you can see that it's actually not machining all the way down the side of this surface. So what I want to do is I want to change this process. So again, viewing from the top. So I'm going to change this to a contact point style boundary. Again, let's apply, show the combined boundary. So now we're using the contact point of the tool against the surface as opposed to the tool center point. So even though our boundary is this circular region, you can see that the tool center point track will actually move outside of that boundary region. However, we're not machining outside of the circular boundary because the contact point is still within that region. So again, let's just preview this. Full simulation first of all. So there's that full toolpath. Again, view from the left, and let's just single step through. So there's tool onto the job, simulate down to this point. Now you can see as the tool is at the base of that position there, the contact point is still in contact with the surface. And again, just viewing from the top, you'll also see that that contact point has not yet violated the edge of that boundary, so it's still staying within that boundary region to fully machine these surfaces.